Hello, welcome to K-means clustering with Python. So for this course, I strongly suggest you to Google some statistical theories, definitions, or examples behind this topic, because I'm just gonna give you a brief explanation on K-means clustering. So K-means clustering is our first unsupervised learning algorithm. So it attempts to group similar clusters together in your data. So what does a typical clustering problem look like? It could be asked you to cluster similar documents or cluster customers based on features, and the features could be their gender, their age, or the payment method they were using, right? And could be market segmentation, and the other example will be ask you to identify similar physical groups. So the overall goal is to divide data into distinct groups such that observations within each group are similar. Okay, so now I'm going to talk about the K-means algorithm. So the first step, we choose a number of clusters. Okay, so in this case that we got k equals to 3. So we usually use k to represent the number of clusters. Okay, so here we have 3 clusters and use different colors to illustrate that. And then the second step, we randomly assign each point to a cluster. Okay, as you can see in this graph, all the data points, they are randomly assigned to a group yellow, group pink, or group green, right? And then for each cluster, we take the main vector of all the points in that cluster and we compute the cluster centroid. So if you look at step 2a, the yellow dot here, it is the centroid of the cluster of color yellow. Okay, it seems like they are a little bit overlapping, but that's okay. And then we assign each data to the cluster for which the centroid is the closest. Okay, say you can see all these data points here. They are closer to the yellow centroid instead of the pink one, or say the green one, right? So we colored them yellow. We put them in this cluster. Okay, and the same to the pink, the group pink and the group green. Okay, and we will repeat those two steps again and again and again until clusters they stop changing. Okay, and then we got our final results. Okay, and then I'm going to talk about how to choose a k-value. You might ask me, say, oh, but how can I know what k-value should I pick? How many cluster groups should I have, right? I would say there is no easy answer for choosing, we say, a best k-value. So one way is the elbow method. Okay, so first of all, we compute the sum of squared error, or we say SSE, for some values of k. Okay, so for example, 2, 4, 6, 8, etc. The SSE is defined as the sum of squared distances between each member of the cluster and its centroid. So if you plot k against the SSE, you will see that error decreases as k gets larger. This is because when the number of clusters increases, they should be smaller, so the distortion is also smaller. Okay, the idea of the elbow method is to choose the k at which the SSE decreases abruptly. Okay, and this produces an elbow effect in the graph, as you can see in this picture.